Alright, let's take a look at some work on even and odd functions here. So we've got this question here that says, suppose that h of x is equal to f of x times g of x. Show that if f and g are both even or both odd, then h is even. So if you remember our definitions from before, to be an odd function or an even function, then f of negative x is equal to f of x. That's going to be for even. And for odd, then f of negative x equals negative f of x. Let's look at the first scenario first. So the first scenario says if they're both even, then h is even. Well, if they're even, then f of negative x equals f of x. So if we're looking at h of negative x, well, that would be f of negative x times g of negative x, which is the same as f of x times g of x, which means that h of negative x is equal to h of x. So that shows the first scenario, just a bit of substitutions here. If we look at it the other way around, well, let's look at negative, so h of negative x, let's just consider that they're both odd here. Well, that would mean that we'd have f of negative x times g of negative x, just like before, but instead of being even, we can make the substitution for them being odd, which means f of negative x is negative f of x times negative g of x. And negative times a negative makes a positive, which means it's the same as what we started with, which means it's h of x and it's even. The same idea can be applied to what we've got here. Let's keep those definitions that we've got there up above. Now look at what we're saying, if one of them is even and the other one is odd, then h of x is odd. So let's look at it this way. Let's just look at this specific time. We're going to say that f is even, and we're going to say that g is odd. So if we're looking at the substitution here, h of negative x equals f of negative x times g of negative x. So we know it's even, which means we can look at our even property for f. So f of negative x equals f of x. And we know that we can use our odd property for g. F of negative x equals negative f of x times negative g of x. That is, as you can see, which is negative h of x, which is odd. And this would work regardless of which way we have it around. So we could do the same property because of our multiplication being commutative, the order doesn't matter. It doesn't matter if we use the other way around, so we make f odd and g even. We can extend this a little bit further. If h of x equals f of x plus g of x, show that if f and g are both even, then h is even. So similar idea. Let's put in those substitutions again. We're showing that they're both even. F of negative x plus g of negative x. We know that when they're both even, from our definitions above, that they're the same. Which is exactly what we started with. H of x, which is even. Because h of negative x equals h of x, language, even. Happy with that. And now we're going to say if they're both odd, h is odd. So let's put the substitution straight in. Now we know that if they're odd, then f of negative x equals negative f of x minus g of x. Plus minus makes a negative. I can factorize a negative out of both of those. And look what we're left with. Negative h of x, which means it is odd. And that's just a bit more of the theoretical properties of our even and odd functions.